have a swimming pool, hot tub, irrigation system, or other connection between an undrinkable water source and your home's water system? If so, you are required to have a backflow prevention device for your home. Normally, water flows in one direction from the source to your house. However, under certain conditions, water can flow backwards through your home's water system. This water can contain harmful substances that can contaminate the public water supply. Once in the public water system, this contaminated water can make consumers sick. Backflow prevention devices act as a barrier, stopping water from flowing backwards to the public water system. They protect you, your neighbors, and everyone else who uses the water system. That is why it is so important to make sure they work properly. They must be tested yearly to ensure proper function. You can have this done yourself, or TVWD can organize the test for you. Visit www.tvwd.org/backflow for more information. Thank you for doing your part in protecting our water system.
Well, good afternoon, and thank you for joining us. I appreciate it. And today, I am happy to introduce Khalil Howell. He's our Senior Water Quality Inspector and joined the TVWD team in September of 2020, bringing a decade of experience as a regional trainer at BMI, which provides training for operator certifications in cross-connection control, backflow testing, confined space safety, and other aspects of water system operations. Cal has traveled to water systems across Oregon, Washington, and California to help them develop their own cross-connection control and inspection programs, and we are pleased to have him presenting to you on backflow prevention assemblies today. Cal recently got married to Hillary, and they are parents to one canine named Diego. Joining Cal today, we have two featured water experts. First is Chief Engineer Carrie Pack. She's a professional engineer and is the district's first female chief engineer, a position that she has held since February of 2016. Carrie has over 30 years of engineering experience in water resources, stormwater, and wastewater engineering. Her team comprises half of the staff working at TVWD. As chief engineer, she leads and manages a team of water professionals who have responsibility for the core mission to deliver clean, reliable, and great tasting water to your home and businesses. The other expert I'd like to introduce today is Bill Richmond. He's our senior water quality specialist and is a certified water distribution and water treatment operator with 21 years of service with Tualatin Valley Water District. Bill manages the district's lead and copper monitoring program. Bill has managed Valley View Water District and offers a deep understanding of water resources. Today, please feel free to have an opportunity, if you got questions, to put them in the question box and type out your questions, and we will respond as you put them. Well, not as you put them in. We'll respond at the end. We'll be doing a Q&A of this, but we certainly like to hear from our customers. And we really enjoy this opportunity to share what we do and know about the delivery of safe, clean drinking water to your home. So with that, I'm going to turn this over to Cal. Cal?
I apologize for that. I had not turned my camera on, so let me get back to sharing my screen here. Okay, well, Tom, thank you again for the introduction. Again, my name is Cal, and I'm glad that all you can be joining us today for the forum. I'm excited to talk about why cross-connection control is so important to protect and maintain water quality for you, our customers. We truly do consider this a team effort that does require your involvement as well, which we'll be discussing here in some of the upcoming slides. Here are the topics we're going to cover in the next 15 to 20 minutes before we go to the Q&A session. This will be somewhat of a broad overview. So if there are any technical questions you have that aren't answered during the presentation, please do ask those at the end, like Tom had said, and post them in the chat box via Teams. So before we can talk about what a cross-connection control program is, we need to first define what is even a cross-connection. So in the simplest of terms, a cross-connection occurs when a water supply is connected to another piping system or fixture which contains a non-potable, also known as not drinkable, substance which can present a danger to the safety of the drinking water. Cross connections typically occur within the plumbing of a building or other types of facilities. Some of these connections can be elaborate setups, such as a car wash with many different water lines connecting to soaps, degreasers, and waxes, to much more basic connections, like something as simple as a garden hose being submerged in a pool, bucket of soap, or even a puddle. So looking at our pictures here, if you follow along with my laser pointer, on the left-hand side is a cross connection I would imagine we have all made at some point by simply taking a garden hose and submerging it in a bucket to dilute a chemical for various different purposes. The middle picture here, it's an underground sprinkler system, which can allow contaminated water to actually drain back into that piping system, bringing any contaminants into the system that you could imagine, like fertilizers, animal feces, and just the hazard of stagnant water out in your lawn. And then the third picture on the right, it's an example of a commercial janitorial sink, which is often connected to chemical dispensers for various cleaning purposes. So this is a very common setup to see in different commercial facilities. Another important term to define is backflow. Maybe you've heard the term before, and backflow is simply when water reverses from the intended direction of flow. Most of us here experience water flow in the correct direction, such as when we turn on a kitchen faucet or a garden hose, water comes out of the end of that fixture. Because this is our typical experience, it can make it difficult to imagine what can cause water to actually flow backwards. At the district, we do a really good job across the system to maintain positive pressure. However, sometimes events like an unpredicted main break or several hydrants opened to fight a fire can actually cause a reduction in system pressure, and in some rare cases, we can lose pressure altogether. These scenarios can cause backflow. Other causes can be from water heaters without thermal expansion tanks, boilers, whether it's a residential or commercial boiler for heating water for different purposes, properties with pressurized wells connected to the home, elevated piping systems such as really tall buildings or a home that is up on a hill, and even as basic as a garden hose that is left out in your yard on a sunny day. The sun will heat the water temperature up in the hose, and it can actually push its way back into your home's plumbing. So a backflow incident is when the non-potable substance from a cross connection actually enters into a plumbing system or the distribution system. The recipe for a backflow incident is when there is an unprotected cross connection that exists while backflow occurs. This is what causes the contamination. If the water from an unprotected cross connection, just as an example, a well, underground sprinkler system, or submerged garden hose enters into someone's plumbing system, it is not only compromising the safety of the water within the plumbing system, but our distribution system as well. So here's just 3 categories of substances typically associated to cross connections. So microbiological contamination from fecal contamination, stagnant water, and other pathogens. Chemical. So of course, chemicals using for cleaning, but there's chemical plants, car washes, janitorial equipment, many examples of simply when water lines connect to some type of chemical. And then there's actually a physical hazard, which can occur by blowing out underground sprinkler systems with an air compressor, to soda machines where the carbon dioxide can actually push its way back into the plumbing system and cause aerated water to flow from the sinks and other plumbing. And soda dispensers, something we've all used before, but it actually can cause a chemical hazard as well. When CO2 pushes its way back in water and then makes contact with copper piping, it leaches the copper into the water, and it creates a toxic substance that we wouldn't want to ingest. So because backflow can at times be unavoidable, the way to protect the drinking water within your plumbing system and the distribution system is the proper installation and maintenance of backflow preventers. Backflow preventers are required to be installed at connections within a plumbing system where the potable or the drinkable piping connects to a non-potable fixture or non-potable piping, also known as simply at that point of these cross connections. So in the first picture here on the left, it's a backflow preventer, which services an underground sprinkler system. We can see the drinking water on one side, which would first have to flow through this backflow preventer, then to the underground sprinkler system where the sprinkler heads are attached to. The second picture might look a little bit more elaborate, but it's to a fire system. However, the same idea applies. The drinking water on one side that must first flow through the backflow preventer, then to the fire system piping. There's many different types of backflow preventers, and they are intended for different applications. Some backflow preventers are mechanical and require annual testing. Some do not require annual testing, and one type is actually not mechanical at all. However, rather than explaining the differences between all the different types, all backflow preventers are designed for the same primary objective, which is to only allow water to flow in one direction, not backwards. One of the most common backflow preventers is one that you all rely on every day and may not even realize it. All of your sinks and bathtubs are actually considered to be an air gap backflow preventer, which is the non-mechanical backflow preventer. If your bathtub or sink were to overflow, you would notice that the faucet, which discharges the potable water, will not become submerged because of the distance from the faucet to the water level. So here's just a small handful of some examples. We have again, if you follow my laser pointer, here's just a standard sink where from where the water discharges is separated from the highest point water can fill in that receiving vessel. This is a apparatus that actually goes on to threaded outlets such as hose bibs, which are a mechanical backflow preventer. Top middle is a backflow preventer that we at the district actually deploy on hydrants for contractors who need water for various different purposes to job sites and things of this sort. Another quick example just of water to an underground sprinkler system where the potable water comes in, flows first through a backflow preventer, then to the sprinkler system. On the right-hand side is the top of a big water tank truck that you may see driving around the district. And these tank trucks, we actually inspect them for proper air gap separation, similar to your sink, where we make sure there's a separation from the discharge pipe to that overflow rim of that tank. So here's just a quick breakdown of one of the more common testable backflow preventers. Its name really says it all. There are two check valves inside of this assembly, Hence, it's called a double check valve assembly. Now, a check valve, it's a valve that will only compress open in one direction of water flow. If water were to try to flow backwards, a check valve is designed to close and seal drip tight. Since there are two check valves, that means there are actually two independent barriers between the drinking water and a non-potable substance. Because these assemblies contain springs, rubber seals, O-rings, and seats, like anything mechanical, these components can wear out, break, or malfunction, which is why the annual test is so important. For this assembly, both check valves would have to fail simultaneously for contamination actually to occur. So just a quick breakdown. On the left-hand side, here's just a complete unit, including shutoff valves and test cocks for the testing purposes. Internally, you can kind of see two check valves in there, but by removing the check valves leads us to the second picture, which are the two internal check valves. These check valves will compress from left to right, but not from right to left. Taking that check valve apart even one more step, we have a breakdown of the components: a check seat, the check disc, which seals into that seat, and then the check spring, which pushes the rubber disc into the seat. This is a common one for those of you that have underground sprinkler systems or residential fire suppression systems. This would be the assembly you'd see typically for that application. At the district, we desire to make water available to all types of customers, from our residential customers, commercial, and even contractors who need water to job sites for various construction reasons. However, while providing water for many different purposes, our primary goal is to maintain our clean, safe drinking water to our customers. The district undertakes a very active, what we call bulk water program, which requires these types of tank trucks to undergo different inspections or an inspection. And basically, we allow these trucks to fill once they undergo an inspection to make sure they have a proper air gap inspection. They are then allowed to fill from these green cap hydrants that we see here. So the truck on the left, we see a proper air gap separation. This truck would receive a permit before it can be out in the distribution system, filling up these hydrants. However, on the right-hand side here, we actually see an issue. So on the right-hand side, this was discovered quickly by our field staff. The contractor was actually found dropping the fire hose into the tank, becoming submerged in the non-potable substance in the container. So this hose attached here that we can see, small, but you can see it, was actually dropped into the top of this tank, submerging into the non-potable substance. And this situation, it was brought to a sudden halt and enforcement actions were taken. You all, as our customers, can also be our eyes and ears in these situations, and we actually appreciate your feedback and giving us a call. If you were ever to see activity on a hydrant and are curious if either the hydrant or that company are approved to do so, just give us a call and we're glad to look into that farther. Just a reminder for those of you that might be joining after we announce this, if you are developing any questions as we're going through this, please drop those in the comment section and we will be sure to address those at the end. So although it seems like we do not hear about many backflow incidents in the day-to-day news, there are actually many backflow incidents that are reported every single year throughout the United States. The reduction in backflow incidents compared to the number of past incidents is a direct result of backflow preventers simply doing their jobs. The more cross connections protected with backflow preventers equals fewer and fewer backflow incidents. Most incidents we read about today are actually due to a lack of proper backflow protection or a failed backflow preventer, which was likely not being tested annually. Here's just a couple examples of recent incidents with real-world consequences. In Boise, Idaho, microbiological contamination occurred from an underground sprinkler system, which allowed contaminated water to enter through the sprinkler head into the water system, resulting in a reported 80 illnesses. The article mentioned that the underground sprinkler system actually had a proper backflow preventer, but was not functioning properly. In Corpus Christi, Texas, up to 34 gallons of concentrated asphalt emulsifier chemical had entered into a distribution system from an unprotected cross connection. This incident was caused by a lack of backflow protection both at the cross connection and at the meter. So now to our program. It's designed, of course, to protect our community's water supply at multiple different levels based on several key elements, which we're going to briefly discuss in the next few slides. So all water systems in Oregon are required to track and enforce the annual testing of backflow preventers, which are protecting the distribution system. Oregon also requires the assemblies to be tested by state certified testers. Many water systems mail testing requirement letters to their customers and leave it up to the customers to hire certified testers. Here at the district, we also require residential customers to test their assemblies, and we have a due date of September 1st each year. However, we do incorporate a customer-focused subscription-based testing program called the Gold Plan. The purpose of the Gold Plan is to help our residential customers meet annual testing compliance without the yearly hassle of scheduling the backflow test and making sure the tester shows up and submits the results to the district. And here's just a few key points to highlight about the Gold Plan. So our plan, it's an optional service to all residential customers. If you would like to subscribe to this Gold Plan, you can visit our website and fill out an application. The subscription fee is $35 per backflow assembly, and this is applied to your water bill each year. And this then allows us at Tualatin Valley Water District to arrange and schedule your backflow test with our certified contracted tester. And if there are any assembly repairs that need to be made, we credit $50 towards that repair cost if you use our certified contracted tester. We hear frequent compliments from our Gold customers via email and phone call about the price being comparable, if not cheaper than other testing prices. The excellent customer service from both our certified contract testers as well as from the district, to just the pure convenience of our set it and forget it type of program. Many customers prefer hiring their own tester, and that's totally acceptable. Here's some things to highlight for those who are not enrolled in our Gold Plan. The backflow test is still due by September 1st each year. To find a certified tester, to be honest, it's best to just ask around, asking your neighbors. They may have recommendations for you. Landscape contractors sometimes offer this service as well. Certified testers, they're required to submit test results electronically within 10 business days of the completed test through the district's tracking software web portal. Assemblies not tested by September 1st will actually be assigned to our certified contracted testers, and a $50 enforcement fee is applied to the customer's water bill. So really, even our enforcement action is still customer oriented. Our main objective is not to penalize our customers, but to meet annual testing requirements for public health protection. So even at that $50 enforcement fee, can be comparable to what some people are paying for just a standard backflow test. Unique to the district, we have implemented a web-based, mobile-friendly data entry application for test report submissions and program management. This approach, it increases quality assurance of our program in many aspects. One would be that only testers with up-to-date credentials can enter test reports into our software. Electronic records are retained rather than paper filing. Failed assemblies, improper installations, and other deficiencies are flagged for quick and efficient follow-up. And the software even has inspection features and documenting capabilities for water quality staff for simple to elaborate inspections performed throughout the district. There are numerous aspects of the district's cross-connection control program that highlight the truly unique and valuable work the program accomplishes. From sending backflow test letters to our customers, goal plan and contract testing, assembly tracking, to the bulk water tank inspections and deployment of hydrant meter backflow assemblies. And then not to mention our engineering and water resources staff who support various efforts from plan reviews for new construction to the daily water quality samples taken throughout our district. And last but not least, your participation as our customers. I always like to say this, rather than imagining backflow requirements on your property as just another expense, it would be better to view it as your participation in the protection of your drinking water provided to your family at home as well as your neighbors. All of these layers ultimately do provide a greater level of protection to ensure safe and dependable water is provided to our customers. At the district, we do dedicate a lot of time, effort, and resources to ensure cross-connection hazards are corrected, with our primary objective, protecting the drinking water we serve to our customers. And then here's just a few things to highlight of those efforts. We are very active to schedule inspections and surveys of plumbing systems to discover these unprotected cross connections and then get those corrected. Working with our customers on timeframes and assistance with the different types of backflow preventers that we may be requiring, and even to the installation of those backflow preventers. We utilize backflow software to prioritize critical inspections needed. And then we do have quick response to customer concerns, from water quality complaints to other things like this. We are quick to follow up with them, do follow-up sampling if needed, and then to come out for on-site inspections of maybe something brought to our attention with the plumbing system. And of course, enforcement is necessary in some of these situations, but our goal is to work with our customers to come to the best solution for both the customer and ours, with the ultimate goal of protecting the water system. So that does actually wrap it up. I want to first just thank you all for taking the time out of your day for joining the discussion on the importance of cross-connection control. I hope you feel you've received something of value, and I'm excited to continue our interaction now during the Q&A. If you haven't already, please do make sure you add your questions to the chat. Also, grab my email address here. If you have any other questions or concerns or topics that you want some more information on, I am more than happy to do homework for you and look into getting your answers, getting your questions answered. So that's completes that.
All right, thanks so much today, Cal. And my name is Justin Dyke, everyone. I am on the communications staff for the Tualatin Valley Water District. And I'm going to be moderating the Q&A today and be leaning on Cal and our other experts, likely Carrie and Bill, throughout the rest of the program today. So Cal, we won't waste much time. We'll get you to your first question. It comes from Tom. What data supports the need for a yearly test of a backflow prevention device? And just a heads up, Dave Nakamura, one of our other water quality experts, did answer a little bit of that in the chat, citing the OAR 333-061-070. But Cal, I'll let you take away the rest of the answer from there.
You're muted, Cal.
Sorry about that. Okay. Yeah, so like I had said, well, you didn't hear me because I was muted. There's not a statistic that I have that I can tell you as far as what prompted why they chose a yearly testing requirement, but that is something that all the states abide by. So any reference material that you look to for the recommended time frame for assemblies to be tested, it was decided annually. So most, or like I said, all states have adopted that same time frame. And I would imagine the supporting data for that is just based upon looking at failure rates of backflow assemblies, because the idea is we want to catch failures before it's catastrophic. All backflow assemblies have multiple barriers of protection. So most of the time in a year span when there is a failure, it's only one of the components rather than all of them. So that way there would still be backflow protection left in that backflow preventer as repairs are being made. So I don't know if that answered your question directly, but I hope that would satisfy what you're looking for.
Thanks, Cal. And the next one is from David from Beaverton. It says, is there any financial assistance available for backflow system installation?
You know, I'm unsure on that. I know specifically with the district, the goal plan provides that $50 credit towards repairs or even installation of a new backflow assembly. But as far as if there's state assistance with that, I'm not sure. If somebody else has info on that here on our Q&A panel, you can chime in if you'd like.
I am not entirely sure if there is anything that I was checking to see if Paul or any of our financial folks were on the line, but I am not aware of any assistance for that.
Yeah, and do send me an email regarding that. Maybe I can help look into that farther and get back to you with a more clear answer.
Absolutely. And again, if any of our other experts do have anything they want to add to that, we can chime in on the chat as well. The next question is, can you put a manual backflow so it does not have to be checked every year?
So that comes down to the type of backflow preventer. That's a great question. There's three categories that are kind of exchanged with one another that shouldn't be. So maybe we've heard of backflow assemblies, backflow devices, and then the backflow method. The method is the air gap, which requires inspection initially. However, of course, we're not coming back to re-inspect sinks and things of this sort. There are backflow devices, which means it's mechanical but not testable. And then backflow assemblies, which are the ones which are testable. So there are certain backflow devices which can be installed that do not require annual testing. Many of those do require very specific installation, and then thereon after would not require any more testing. And so I guess an example of one of those that some customers may have even on a lawn sprinkler system can be atmospheric vacuum breakers, an AVB. And although those don't require annual testing, we actually see many times that they're installed improperly where they're not stopping backflow as they should. So we would need to require those to be installed properly before we can allow them to be relied upon for backflow protection.
That's great. Thanks, Cal. We got another one related to sprinkler systems. This one is, our sprinkler system backflow preventer box needs fixing. The dirt is caving in. What kind of company can help us fix this?
I would say your best bet would be looking to a landscape contracting company. So they do that very often. They dig up old crushed boxes and backflow assemblies and repipe everything. And they can even do elaborate setups like putting some type of screen on the bottom to prevent it from becoming buried by moles and things like this over time. So landscape contractor, probably your best bet.
Great. And keeping on the theme with the sprinklers, the next one is, we don't have an underground sprinkler system and only really use our hose to water plants. Do we need a backflow preventer?
So for those either using a garden hose, such as attaching just a hose attachment that you're going to go and manually turn on and water your lawn, the main thing to just make sure is that you would actually have a hose bib vacuum breaker, which is installed on the threaded outlet to your hose bib. And those could be, you can go to a Home Depot, a Lowe's, Amazon, and they can be as cheap as $10 up to $30 for these different hose bib vacuum breakers. The one thing you would want to keep in mind, however, is those are meant for intermittent use. So if you were to go out and manually turn on your hose bib to a fixture of some, or a watering feature of some sort, and then you turn it back off, it needs to depressurize afterwards. So what we see that is not correct sometimes is a hose bib vacuum breaker on the threaded outlets, and then an attachment with shutoff valves on the downstream side that then tees off to many different features. And this actually causes those hose bib vacuum breakers to malfunction because they stay under constant pressure. But to answer your question, just quick and direct would be making sure you have a hose bib vacuum breaker attached to your threaded outlet.
All right, that was great. And we might also, on this next question, be asking Bill to join in. This question is from Jess from Cornell Height. Water is yellowish. Is it caused by the backflow issue? Is the yellowing water still drinkable? We enrolled in the auto annual backflow test in your system. Any way to receive the test report?
So let me answer the first half, the second half of that, excuse me, and then I'll let Bill jump in. As far as if you're wondering about the backflow test report, yes, we have that and we can provide it to you. So our gold customers will receive a door hanger that gives you a general pass or fail on the backflow assembly, but we have a more detailed backflow report that will tell you what each of the check valves in the backflow assembly actually performed at. And then I'll hand it over to Bill when it comes to the discoloration.
Thanks, Cal. Hi, this is Bill. I'm in the Water Resources Department as well, as was introduced in the beginning of Cal's presentation. So yeah, I could try to take a stab at the issue with yellowish water as you describe here. Is it caused by a backflow issue? Short answer, probably not. There's a few things that could cause discoloration in water, one being home plumbing. So if this is something that clears up after a period of 30 seconds to 1 minute, generally speaking, it could be due to home plumbing if it's an older home with either copper or galvanized plumbing. Also, there could be some flushing going on in the system or hydrant use that oftentimes will stir up a little bit of sediment in the system. Not to worry, that discoloration is almost always just due to that fluctuation change within the water. It's all disinfected still. We address this question particularly in pretty good detail on our website as well. So if you want to check out more information on that, but yeah, so if there was a cross connection and there was water backflowing into your system, more than likely you'd be experiencing more than just discolored water, probably a drop in pressure or a change in pressure flow. Certainly that discoloration, possibly smell and taste. So there's a lot of things that go into that. I don't want to hijack the whole conversation here, but I'd be happy to answer more of those questions. I think they provided my email as well in the beginning, so you can contact me via email to follow up on that. Hope that answers your question.
Thanks, Bill, and it was definitely good to give Cal a little bit of a break there as well. Next one came in late. Do you have to have a test if you do not have a sprinkler system? Cal, I think that's going to be right up your alley as well.
So we've used the underground sprinkler system as a common reason or need for a backflow preventer. So if you don't have an underground sprinkler system or a residential fire system, there may not be any other need for a backflow preventer on your property. So really, wherever the plumbing code requires these backflow preventers to be installed, would then be our need for the testing to be fulfilled. So for instance, like a residential boiler, that would require in some cases a testable backflow preventer. Like I had mentioned, the irrigation systems and the fire systems, but those are your typical residential backflow preventer requirements necessary. So if you don't have one, likely, if you don't have a sprinkler system, likely you don't have one that would need to be tested.
Awesome, thanks, Cal. Next one is from Devin. Is this excellent presentation being recorded so I may share it with coworkers that were unable to attend? Yes, I can answer that myself. It is being recorded. It will be posted at tvwd.org/talkinwater. That's TALKIN water. After we get it uploaded to YouTube, and I put that web address in the chat earlier. Feel free to check back later. We'll get them posted pretty quick after the presentation ends. Next comment is from our Commissioner Jim Doan. Thanks for captioning. It's very helpful to me. Thanks for joining us today, Commissioner, and hope you're having a good day today and the heat's not too much. And next is from Jess from Cornell Heights again.
Justin?
Yes.
Sorry, I just wanted to chime in. I don't know what it emptied from my mind. Some other things that could require backflow protection would be like a pool or a hot tub. Some pools that are in ground may just have a hose that someone may fill it with, and then the hose bib vacuum breaker would be proper protection from that. But there's some pools that have submerged fills, which would then have a testable type of backflow preventer. And so that would be something, if you are wondering how your pool may operate, we can you can reach out to me and we can kind of discover if you do need that backflow preventer or already have one. But yeah, hot tubs and pools would be another time that those backflow preventers would be required.
Awesome. And keeping on that theme from you, Cal, the next question is, what is the phone number or email address for customers to report a water quality program? Bill jumped in the chat and responded, and I'll go ahead and read that. The easiest and quickest way to receive a response from the water quality team would be to email wq@tvwd.org. That email address is in the chat. Feel free for everyone to use that as well. And if not, Cal or Bill, someone on their great team will respond promptly. The next question is going to be for you again, Cal. Is a permit required to install a backflow preventer or to install a residential sprinkler system more generally in unincorporated Washington County?
Yes, so you'd want to make sure because you are altering or extending your plumbing system, that does require a plumbing permit. And one of the most important parts of that permit is that they're going to verify that that backflow preventer is installed. And then that's what brings it to our attention at the district to begin the tracking of the testing of that backflow preventer.
And thank you for that. To keep on that track, we have a question from John. How often do inspectors find failed backflow assemblies?
Gosh, so I don't have a statistic again to give to you. Let's see. So let me just start out by saying it's not uncommon for double check valve assemblies or some of these other assemblies to have one of the components malfunctioning. So that part is not uncommon. And then I would say to run into the scenario where a backflow assembly is failing to the point where it would not stop backflow, that's rare as long as it's getting an annual test. So we don't see many of those throughout the year. Most assemblies that do fail, there are still functioning components within the backflow assembly that will stop the backflow in the meantime while the repairs are being scheduled and completed. Probably didn't answer your question very directly. If you want to email me, I can see if there is a statistic that I can get for you.
Awesome, thanks, Cal. And then looks like we're getting toward the bottom of the list. Tom, you got something you want to say?
Yeah, just an anecdotal on that. I have had my own personal backflow device not pass before. So it does happen. I also don't know the frequency of that event, but it's certainly, especially with backflow devices that are not under constant pressure. So like your sprinkler system, when you blow it out in the winter and it's dry and then you recharge it in the spring, that is actually, I believe, a little more frequent for those to fail, to get a little bit of debris in the seal, and then those seals no longer hold back the flow. So what I want to make sure that you understand is it's not zero. I just don't, I couldn't statistically, like Cal, I couldn't tell you. I hear of the events, I hear about when they happen, but I don't know if we've got a track record on that.
And I guess to piggyback on what Tom had just mentioned, so from my past experience, I've also done a lot of backflow testing. So there's been days where I would test, let's just say, 40 backflow assemblies in a day, and it wouldn't be uncommon to see between 5 to 10 of those failing. And again, not catastrophically always. So it would be one check valve or another, not both of them failing too frequently. But I do remember several times a brand new backflow assembly failing catastrophically to where both check valves are not functioning. And to kind of just emphasize what Tom had said, when these assemblies are repressurized, can be a common time for failure. And actually the highest time or the highest percentage of assembly failure is in a brand new installation. And this doesn't mean components on the inside are typically broken. What it means is material from the installation, such as PVC glue, Teflon tape, metal shavings, any debris that got into the piping while it was exposed to the environment, gets flushed into that backflow assembly upon installation and holds those check valves open. And which is why one of the most important times to get an assembly tested is immediately upon installation, then annually thereafter. And a lot of that does have to do with the quality of the installation work. So plumbers and landscape contractors that flush that water line out for a good amount of time prior to the installation can prevent these failures upon installation, but some of it is unavoidable.
Awesome. Thanks, Cal. And
I think Dave wanted to chime in on that.
yep, I was about to say, Dave, I saw you turn your camera on.
Yeah, not to chime in on the current question, but the previous person was asking if a permit was required for backflow preventer, where they wanted to install the residential sprinkler system. I just want to make sure for the folks that are just listening and don't have access to the video part of it and the chat that's there, please make sure that you call locate services anytime you're digging in your yard, just to avoid any underground utilities. That's always the safest way to go about things.
That is absolutely a great point, Dave. Thank you for jumping in with that. We appreciate it. And it looks like we're coming up to one of our last questions. And Cal, this will be for you. Do all residential customers need backflow prevention methods? How does one know if they have them or not? First-time homeowner, and congratulations on becoming a homeowner. Cal, take it away.
Yeah, great question. So again, similar to earlier, it would be based upon what features you may have to your plumbing system. So if you have a pool, you'll likely have a backflow preventer. If you have an underground sprinkler system or residential fire system, you'll likely have a backflow preventer. Now, if you're in a situation where you don't have any of those and the extent of your plumbing system would be your typical outside hose bibs and your typical residential water heater and your sinks and faucets, and that's all, that would be a scenario where the only backflow preventers that you would have would be those hose bib vacuum breakers, which are actually not required to be tested. Those ones are simply required to be installed on the threaded outlet. So hopefully, as you kind of ponder your new plumbing system and what you have there, that would answer it for you. If you still have questions on that, again, please email me. I'll exchange. If you want to send me a picture of something you might think be a backflow preventer, I'm more than happy to investigate that with you.
And to follow up on that one, this person submitted another question. Who would I contact to get such a permit, and what is its cost?
So if you're within Washington County, that would be where you get a permit for the installation of the backflow assembly. And I don't know the cost right off the hand, but I know it's right around the $120 to $130 range. But ultimately going to Washington County's website would provide the exact price for that permit.
And then I believe we are up to our last question. As a reminder, we'll be closing out quickly after we finish these last questions. So if any other folks have questions they want asked, please go ahead now. But this last one is from Gail. What type of water heater needs backflow protection? And Cal, this will be for you again.
So what your typical residential water heater actually does not need backflow protection. Earlier in the presentation, we talked about residential boilers, and that's different from a water heater. A boiler sometimes is used for recirculating hot water to, let's say, a hydronic floor heater or heating a pool or something of this sort. Now, your standard residential water heater, it's potable water going in, potable water going out to your faucets. What I did bring up earlier in the presentation, however, is it can push water backwards. So what happens when no one's at your home and no one's using water, when water is heated up in temperature, it expands, so it takes up more space. And so if your tank doesn't have a thermal expansion tank to absorb that extra 1.5 gallons or so of water volume, it pushes its way back through the water line that's supposed to actually fill the water heater, but it's not necessarily a contamination issue because the water in a water heater is still considered potable or drinkable.
Awesome, Cal. Thank you so much for answering all these questions. That is everything we have on the list for questions today. Thanks again to all of our customers for attending this edition of Talkin' Water. Thanks to Cal And thanks to all of our experts and Tom for joining in today. Again, please visit tvwd.org/talkinwater for the video later, and any questions can be emailed to wq@tvwd.org to get one of our great water quality experts and have them answer any more specific questions for your home. And with that, again, thanks for your time, everyone, today. That wraps up this edition of Talkin' Water. Thanks, and see you next month.